Okay, in this video, I'll show you guys how to approximate integrals, and in particular, we'll be focusing on the integral from 0 to 1 of cosine of x squared dx. This is a famous one. Some of you guys may comment this is the first integral. Yes, but that's later on. And if you want, you can try to do some usual technique to integrate cosine of x squared, but I'll tell you, it's not going to work. In this video, I'll show you how to use the Simpson's rule and also Taylor series to take care of this for you guys. And after you guys finish watching the video, be sure you leave a comment down below and let us know which method that you like more. And this right here is also a really good practice question for your Cal 2 class, especially if you have to take your Cal 2 final soon. And best of luck on that as well. Anyway, we are going to start off the Simpson's rule. Here we go. This integral is approximately, by the Simpson's rule, I will write down the formula for you guys first. We have the delta x over 3. And why over 3? You can just imagine you're using parabolas to do approximation for this. And when you integrate parabola, when you have the x squared term, you get the over 3, right? And be sure you guys go check out Brilliant.work because they have detailed explanations on the Simpson's rule. I will have the link in the description for you. And then next, you are going to multiply by f of the first x value. So usually we just write it as x naught like this. And then next, right here, you are going to multiply by 4. 4 times f at the next x value, and we just write it as x1 like this. And then next, you are going to be adding 2 times f at the next x value, which we'll just write it as x2 like this. So the idea is that you begin at 1 right here, and then 4, 2, 4, 2, 4, 2, and so on like this. And this right here, I'll just put down plus, dot, dot, dot. But it has to stop. This is only finite, okay? And I'll just write down the last one right here. When you have the last one, it's just going to be 1 as well, just like the first. So you just put down f at the last x value, and we'll just write it as xn for this. Okay? And now, you have to remember the one before the last one, so the second to last one right here, it's actually also 4 times f of x at the previous x value, so I'll write it as n minus 1, like this. So, you can imagine 1, 1 on the very outside, and then 4 fours, and then 2 twos, and so on. So, here are the things that you have to remember. First of all, this is the notation. Right here, this right here is just going to be my first x value. And you can also call this to be a or x naught, doesn't matter, but I'll just call this to x naught. And then this right here is the last x value, which is this. This is just going to be xn. And once again, this is the traditional a to b, so you can also use that, all right? And the function, of course, this right here, so it's label f of x in our case is cosine of x squared. Now, what is delta x? First of all, you have to know the interval, the length of the interval that you are integrating. In this case, we have 0 to 1, right? So for delta x, what you are going to do is you are going to do xn, and some people do just put on b minus a, which is okay. Xn minus x naught, this is okay. And then divided by however many interval that you want to use. So divided by n. However, here's the catch. So right here, n has to be even. And in fact, I'm going to make this fair for both methods. Before we start, we have to choose an n value, and the n value has to be even. And perhaps I will just write this down right here. We will be using n equals 4. Because if I use n equals 2, that's too lazy. If I use n equals 6, that's too long. It's no good. N equals 4, I think is just about right. And then right here, I'll also be using the first 4 non-zero term for the Taylor series expansion for this right here. So 4 and 4, right? This is how it can be even. Okay, so here we go. We are going to let n to be 4. So if you would like, you can just calculate delta x first. Delta x is just going to be 1 minus 0, and then divided by 4, so it's just 1 minus 0 over 4, which is just 1 over 4. So that's pretty much it. And then, let's see. And usually we'll just write this down as n. And I will just write down this right here as n, which is now as 4 because we're using 4 for this. this is equal to, because this is the name of the Simpson's formula, delta x, which is just 1 over 4, and then you always divide it by 3, all right? And then you are going to multiply by, okay, what's f of x naught? Well, x naught is 0, so we just have cosine of 0 squared. So perhaps I just put this down, cosine of 0 squared. That's the first, And then next you add 4. And then what's the next x value though? This is what you can do. You can just make a quick sketch right here. You go from 0 to 1. And you are going to cut this into 4 pieces. So you have this, that. So this right here is 1/4, 2/4, 3/4. And then last one is 4/4, like that. So it shouldn't be too hard. The next one is just cosine. And then you are going to put in 1/4 into the function. So it's just 1 over 4. And then you square that like this, right? And then you just continue. And then the last one, hey, is at 1. And look at, the one before the last one is 4. And that's exactly what I said. So anyway, the last one, the coefficient right here is 1. And you have cosine of 1 squared, right? So that's pretty much it. And in the end, you are just going to use your calculator to do this. But the good thing is that you can just use a pretty decent scientific calculator. Anything that has cosine, right? That's all. And be sure your calculator is in the radians mode, right? And if you use a calculator, you are going to get approximately 0.90401, right? Like this. So this right here is the answer from Simpson. Thanks to Simpson, we have that. Now let's talk about Taylor. Yes, this is the dad. I don't know what you want to call Simpsons. Maybe, I don't know, man. Just leave a comment down below or whatever. Because the uncle is Lagrange, so I don't know. Yeah. Anyway, to take care of this, as I said earlier, we cannot integrate cosine of x squared. But if we change this to the Taylor series form, then we can just integrate them term by term. So thanks to the dad, Taylor, let me write this down for you guys. We have to know that cosine of just x, what this is going to give us. Notice you have the even powers and also the even factorials. And then this right here alternates. So this is how you can remember cosine x. Here we have cosine x squared. So what we will do is, well, this is the integral from 0 to 1. I will just plug in x squared into all the x right here. So let me just write this down right here for you guys. And as I said, I will just use the first 4 non-zero term. So the first term is still 1 because when you plug in, there's no x right here. Next, I will have minus, and then I have x squared. I should also color the square to be red. I plug in x squared into this x, and then I will square that. So I get x to the 4th power, and then divided by 2 factorial. Next, I put x squared right here, and then raise that to the 4th power, and then you just multiply the powers. So we get x to the 8th power, and then divided by 4 factorial. And of course, you can multiply the factorials now, but I will leave that to you. Lastly, right here, this is minus, and then you put x squared right here, square, and then raise to the 6th power, you get x to the 12th power over 6 factorial, like this. And then we're going to just stop right here. That's why I only put down an approximation, because I'm not going to keep on going forever. So I put on dx. How wonderful is this? Remember back in the days you had to do integration by parts, partial fractions, trig sub, whatever sub, right? Now, thanks to Taylor, once you change this to the Taylor series, we can just integrate this term by term. And this is going to be really easy. I'm going to put an equal sign because this is equal to that. But in the end, this will give us approximation to whatever we get right here, right? Anyway, integrating 1 in the x world, we get x. Integrating this, you add 1 to the power, which is 5, and divided by that. So you have minus, and let me just write down x to the 5th power over 5 times 2 factorial. And then we add, and then you add 1 to the power, so it's x to the 9th power over divided by 9 times 4 factorial. And then minus, you add 1 to the power, which is 13, and then divided by 13 and then multiply by 6 factorial. Oh my god, life is so easy when we have Taylor to back us up. That's why this is the dad. And then, of course, don't forget, we go from 0 to 1. So when you plug in 1 in here, of course, it's just 1. And then minus, this is just 1. And multiply this out if you want. This is 5 times 2 pretty much, so it's 10. And then you add, put in 1, so it's 1. And then over. This right here is, well, 4 times 3 times 2, which is 24, times 9, which is 216. And then this right here is minus, on the top it's easy, it's 1, over 13 times, this is 720, so 9,360. And we're done pretty much, because if you plug in 0, everybody has an x, so you're pretty much just minus 0 right here, so it's like a big 0. So this is pretty much the idea. And notice, you don't need any fancy calculator, because this right here is just fraction. So you can just add this up and then get approximation. If you don't like approximation, you can just get your common denominator and all that, and that will be pretty cool. But I will give you guys approximation so we can compare this with that. If you use Taylor series right here, we get 0.904523. All right? So this right here is the answer from the dad, Taylor. Well, at the moment, I'm not telling you guys what the answer is by using like advanced calculators or computer. This is the answer that we got from Simpson's, and this right here is the answer that we got from Taylor. And as you can see, 9045, 9045, it's pretty close to each other, right? So they are, they agree to a certain degree. Leave a comment down below now and just think about which one do you guys think is going to win right here, right? So just pause the video and think about it. Go ahead and do it. So hopefully you guys actually just look at this and then think about which one you think is actually going to win. And now the moment of truth, the answer to that is 0.904524 by using Wolfram Alpha or any kind of computer software or maybe a graphing calculator. And as you can see, in this case,